And it works without the computer. See?
Okay, well, hello. It's been about 6 years since I made the channel, and I haven't actually made anything for it yet, so this is officially Hello World. And on that note, I'm going to do a little project here with my kids. So, hello, I'm Tech Yeti, and this is Sister Yeti. And wave your hand in there. There we go. Then we've got Brother Yeti. That's there. There we go. There's his hand. And we have Mrs. Yeti. Okay. She'll probably be a rare sighting here because the kids are a little more excited about electronics than she is. But today we are going to do the Hello World Arduino project. My wife, Mrs. Yeti, she got me this awesome kit for Christmas. And yes, not this Christmas because it hasn't happened yet. It's been a year and I haven't actually opened it yet. So this is a really cool little kit. I'm going to now show the kids some of the fun things you can do with it. One of the things I've always wanted to do is play with the LCD, and there we go. Right, so right now that's not set up. It still has the plastic on it. Let's see. Okay, I got that before she did. Okay, so we got the LCD. I already put it on the breadboard because it's a little bit of a pain to get on there, so I didn't want to take it off and put it on again. We have our Arduino. We have a breadboard with a display. Now, what is the breadboard? A breadboard is used for poking little things in it just for when you want to experiment with stuff. Say I have these wires here and I need to wire something up to over there, right? There's little holes in it, right? So I can push the wire into the holes to connect things together. I will show you more of cool things that you can plug into these over time, but today we don't have time to do a lot, right? I just want to show you how we can connect this, which is called an Arduino, and plug it into that and make it show the hello world that we have over here. Okay?
Okay.
So, what is the Arduino? An Arduino is a little computer, actually. Not in the same sense as the computer that we see over here, right? It doesn't have a screen, it doesn't have a keyboard, it doesn't have a mouse. This is a microcontroller, this little chip here. And it's used to control things. And it's small. So, it's a microcontroller. This right here has a bunch of little holes in it. Notice how it has holes similar to the breadboard. So what we'll be able to do is connect things from the breadboard, or rather from the Arduino, to the breadboard. Okay? Now, once we have everything connected, we're going to have to write some code. So you've done some Scratch. That's cool, right? You've made Scratch move around. What we're going to do here is we're going to write some code. This is going to tell the microcontroller how to tell the display what to do. Okay? So let's go ahead and come back to the instructions here and skim through this first bit. So this is a picture of what the output's going to be at the end. And we're just going to skim over some of these things here. Anyone who's watching can stop and read these directions. There will be a link to these directions in the description. But there are a couple of pins. Okay, so what is a pin? There are a bunch of little things here on this board, right? So there are labels along all of these pins. There's 16 pins here. And we've got, can you read off the first one?
VSS.
VSS is the first one. And the second one is VDD on mine. The directions say VCC, mine is labeled VDD. We have V0, RS, RW, E, and then D0 through D7. So that D means data. So data is the information that we're pushing back and forth. So when we want to put an H here, we have to put the right number, the right things on the data lines to make the H show up. I'll explain how that happens some other time. Today we're just going to plug it all in, see it work, okay? I spent years of my life trying to understand how all of this happens. So I'd like to explain it to you guys in a way that maybe makes a little more sense a little quicker doesn't take you until you're 21 to figure it all out. So there is an enable pin that enables writing to registers. What that means is when the code tells the enable pin, the Arduino, to set the enable pin high, it can then accept information, and then you then read and write sets it to read or write. In our demo here, we're only going to be writing to it, never reading from it. And so we'll wire it up in a way that will make that happen. And then the data pins, I already talked about those. There's also a pin that will set the contrast, basically how dark the display is. Okay, and then there are a couple pins also to set the backlight, to turn that on. Okay, so we need to hook up all those pins. We need to hook all those together or the Arduino can't do anything. So we're going to need wires. Okay, and this is called a potentiometer. There's another name for it as well, but I always forget what the other name is. I call it potentiometer. This right here, it spins. Okay, this is how we're going to adjust the contrast. I'll explain how that works a little bit better later, but basically it is a resistor. This is a resistor, and this is one of those things I'll explain better later when we go into a video about like how electronics actually work. But a resistor makes the electricity, it basically like tells the electricity to slow down. Okay? Now what actually happens is a little more complicated than that, but just so you know, it's kind of like it sets the speed limit for the electricity. Okay. Keeps it slowed down. Okay. So this, when you turn it, it changes what the resistor's value is. This resistor right here cannot change. It's solid, right? But this one, as you turn it, it changes how much resistance there is. And that changes how fast, if you will, which is not a good analogy, but it changes how much electricity can get through.
Cool.
Cool? Okay, so let's keep scrolling down this these instructions here. Okay. And it says for the code we need a liquid crystal library. So if we bring up the code, we're not going to do it right now, but over here in the IDE, we have, sorry, technical difficulty. You can grab my keyboard here to bring everything back up. The code is in the Arduino IDE. And if you click on this button here, we'll see the libraries that are installed. And I've already found liquid crystal by typing liquid in here. And then I installed it. Okay, and let's go ahead and hide that away for now. So liquid crystal is already ready. I've already done that over here in the IDE. And let's go ahead and just back to the instructions for a moment.
Yeah.
Hardware required. I've already pulled things out. Oh, and we're going to skip this paragraph here. Basically, you can wire it up in one way that is a little simpler. We're going to do the simpler way. We're not going to use everything that this display can do today. So we're just going to wire it up the more simple way. So we need the Arduino board. We need the screen, which I already have on the breadboard. Okay, we have the hookup wires. I've got these all here already. The resistor, I already grabbed. The 10 kilo ohm potentiometer, right? So it's, this has a 220 ohm resistor. This is 10 kilo ohms. That means it can resist a whole lot more. And then we have, this LCD already has the pin headers on it. So we need to wire up the circuit. There's a note here about different Arduinos, but we're using the one that this is intended for, so we don't need that note. Now, this chart here shows us what we need to do. Okay, now it's got a bunch of yellow wires, and it has some red and black wires, and it shows the resistor and things like that. So I have already done this earlier today to make sure that I knew how I was doing it, how to work it.
So?
Okay, and I got it all working. Now we're going to do it again.
Okay.
So, first thing is there are some there's some things that we need to plug into the Arduino, and I'm going to start with a couple of orange wires. Okay, it helps to have colors to tell things apart. I'm using orange here. It's yellow in the diagram here. You can see these two are yellow.
Yes.
I'm going to use orange just because these two are separate from those four. Okay, so I'm just going to use orange to keep them, to tell them apart. Now, the LCD RS pin. So if we look at the board, you find RS. Sister Yeti is looking for RS pin here off screen. Okay. Brother Yeti's now finding it. It's the fourth pin. Okay, the RS is right there. It's the fourth pin. So we're going to take an orange wire and plug it into the breadboard lined up with the fourth pin. So what the breadboard does is all of the pins over here are connected to each other, and then there's a gap.
Why is it called breadboard?
You know what? That's a great question. I'll have to look that up sometime. Why it's called a breadboard, I'm not sure. But then these pins over here are separate from the ones over there. But in a line, they're connected. And so the breadboard connects the pin 4 to this orange wire inside of the breadboard. And we also need, and then this one goes to pin 12 on the Arduino. See the number 12 there?
Yeah.
Okay. Right. So we've plugged that into pin 12 of the Arduino. So let's keep moving along. I'm just going to start plugging them in because I don't want to take too long, but we're going to plug one into 11, and 11 is the enable pin, and that is the E, which is the 6th one. So we're going to skip one over, and plug that into E. Okay. And I put the screen all the way to the left so that my cables will actually reach, because the orange cables I have are short. Now we need to do the 4 yellow cables for the data lines. Okay. So the data ones are going to start on pin 5 on the Arduino. Very good. And then it goes to D4 on the board, which is over here. Okay, so we skipped 0, 1, 2, and 3. All right, this has that paragraph we skipped that talked about a more complicated way of wiring it up. That's 8 pins versus 4 pins. We're just using the 4. And then we're just going to go to the next one, which is 4, and go to D5. And we're going to go to pin 3 and go to D6. And these numbers will matter when we write the code, okay? And then we're going to go to pin 2 and go to D7. So the Arduino has these 4 pins hooked up to these 4 pins. Okay, and then these 2 up to these 2. So when we write the code, we're going to tell the code, use these ones to do what the LCD panel needs on those pins. Now we need power. Okay, so we need to power some things. But first, there's actually one thing. Remember I said we're never reading from this, we're only writing from it. So we don't need to control the RW pin. The RW sets it read or write. We don't need to control that one. We just want it to always be in read mode, or write mode, sorry. Because we always want it in write mode, we're just going to set it to ground. And it won't change. It's just going to be that the whole time.
Oh, so the black ones is there to there.
Yep, black one went from there to there. And the black one is the negative, or ground. This is DC. We can talk about DC versus AC some other time. But this is all DC power. And so we like to use red and black. And no, I do not know why red and black. Look that up sometime. But we use red for the positive and black for the negative. Very good. Like a battery. You know how a battery has 2 sides on it?
Yes.
Yeah. So there's the positive end and the negative end. So the red would be the positive and black the negative. So we cooked that pin up to negative. Now we're on the VSS pin. Okay. So VSS is also going to GND, which is ground, which is the negative. And VSS is the very first one over here. Okay.
Yeah.
So we're going to hook that over to negative as well. So notice I'm pushing it over here on the breadboard.
Yes.
These aren't connected to power yet. The breadboard isn't connected to power yet, but what we normally do...
Getting the chair to sit on.
Well, it's too far away. You can't see from sitting over there. If you put the... we're going to hook power from the Arduino up to these 2 over here. There's a positive one and a negative one. we haven't hooked those up yet, but we're going to do that later. And so we can hook one cable to this whole line, and it makes it easier because we can hook up 3 or 4 things to this line and then only one to the Arduino. So the next thing we need is VCC power to 5 volts, which again on mine is VDD, I'm not sure why. But we're going to put that into the second pin here. And you can follow along on this chart as well. If you follow the lines, you can see that there's a black to the first pin and there's a red to the second pin. So we're going to put this one over here to the red. Okay. Now we need to power the backlight. The backlight, we need that so we can actually see really well, what's actually going on. So we need to put that through a resistor. And that's because the backlight would burn out. It would break the backlight if we just put it straight onto 5 volt power. We don't want it right onto 5 volt power. So we're putting a resistor between the pin for the positive side of the backlight. Okay, I'm gonna see, got that in there. And I'm using some pliers because this wire bends really easily, and if I don't use pliers, it just kind of flops around all over the place. So then I'm going to push that in and then use the pliers to push that all the way into the hole. Okay. So now we need the black for the negative. On my board, they are labeled A and K, so A for anode, K for cathode. Might have that backwards or wrong or something, but that's what I believe it means. It has to do with how LEDs work, but it's red and black, okay? We didn't use a red wire because we needed the resistor. So I just used the resistor instead of a wire. Okay, now we have all of these hooked up except potentiometer.
Yes.
So in the graph here, in the little chart, oops, no, didn't mean to do that, but there we go. The potentiometer is off to the left. Well, I have a bunch of wires there, and so I'm going to put it over here. It doesn't matter where it goes, it just matters that it's hooked up properly. So I'm going to put it over here somewhere. Actually, you know what? I'm going to grab the blue wire first and see how far it reaches. See, this blue wire is over to the 3rd pin, which is the V0 pin. This one is used to tell the board how dark the letters should be. And I can reach it to over here somewhere.
Blue one.
So I'm going to put it there so it's kind of flat.
I have a blue one.
Yeah, a blue one. So I'm using a blue because that's what the chart has, and it makes it easier to, the schematic is using blue. So it makes it easier to tell what I need to do if I use the same colors. Now I push this in, okay? And now I can spin this around. And what this does is it takes the 5 volt power that's coming in, and then I'm going to use this to split it into a different voltage. So I need to hook it up also. So let's go back to the full size one. So I need a red on the right side. So on the right side here, I'm going to go to power. I'm going to stretch it over here just so it's kind of flat and out of my way. And then I'm going to put a black one on the left side. And again, I'm going to stretch it over here so it's kind of flat and out of my way. Okay, so that's the display all hooked up. But we still need to hook up ground. I don't know why the diagram has ground from the top. I'm going to pull it from the bottom. But either one would work. So now I've got this ground pin on the Arduino that goes to the negative line. Yeah. And now on the Arduino there's 3.3 volts and 5 volts. This is a 5 volt panel. So we want to go from the 5 volt over to the positive over here. Okay. Now it's all hooked up. And in theory, as soon as we plug this in, we should see the backlight turn on.
It turned on.
It turned on! You can't see it on camera, but Sister Yeti just covered her mouth in excitement. So that is working. What do you think, Mrs. Yeti? She's just nodding. Okay, so the backlight is on. Now, we need to do some code. Let's go ahead and not scratch that around. So if I scroll down here, this is another version of the diagram. This is a wire schematic. We won't bother with that one today, but it's just another way of telling us what this one's doing, okay? So we're going to come down to the hello world example. I was explaining this to Mrs. Yeti recently. It is very common in software for the very first thing you do in a new language is to print hello world. Just a way of saying the computer is now in a state that it can say hello. And that's why I started the video with hello as well. Because this is hello world with an Arduino and a 16:2 LCD. Now, it's a 16:2 because it's 16 characters wide and has 2 lines.
Oh.
So I'm now going to pull over my keyboard. Mrs. Yeti, can you pass that over, please? Thank you. I had it off my desk so it wouldn't be in the way earlier. Now, when I go to the IDE here, we're going to write some code over here for the Arduino. The code is already in the example, okay? There are a lot of comments here. There's a bunch of parts here that are gray. These are comments. These aren't part of the code. They're just saying what's going on. And these particular comments are just saying this is how it's wired up. And so we're not going to put that into our code. You can, if you want to, you can copy it over. But it's just saying that these are how everything's wired up. I'm not going to bother copying it over because we actually have to do that here to make it work. But the very first thing we need to do at the top is we need to include the liquid crystal library. So remember earlier we talked about how we needed to come here to make sure liquid crystal is installed.
Yes.
So in the code, we're using this thing called include to tell the code that go find the liquid crystal code and include it here. We want access to the liquid crystal code in our code. So there's a lot of code that we'll go over some other time that was already written that will do all of the stuff that we want to talk to this display. And this is an LCD display, liquid crystal display. That's what LCD stands for. So we have an LCD here. Now we need to get things set up. The code doesn't know what pins we used on the Arduino, and that's what we're going to do here. We're going to write some values in that will tell the liquid crystal code what pins are being used on the Arduino and where they connect to on the LCD.
Oh.
If we don't have those lined up properly, the code will try to do something, it'll talk to the wrong pin, things won't go wrong, maybe you break something, yeah, right. Probably won't break something, but it won't work if it's not right. So we're going to have an RS, and that was on pin 12. So the RS on the LCD is hooked up to pin 12 over here. Right? We also had the enable pin, and that was on 11. And then D4 was on 5, D5 was on 4, D6 was on 3, D7 was on, scroll over a little bit,
2.
And that's the end of the line, so we put in a semicolon. And then we're going to take a liquid crystal we're going to say we want a liquid crystal object from the code here. We're going to call it an LCD, and we're going to pass in RS, the enable, and then D4, D5, D6, D7. What we're doing is we're telling the liquid crystal code, these are the pins, and this is what they're connected to. These are what you need to talk to the actual LCD. So if we had wired this up differently, say we had wired this to 13 instead of 12, right? Then we'd make that number 13. Okay? We could have just put in 12, 11, 5, 4, 3 here, but then when you look at the code, you can't tell what it's doing, right? So we labeled everything so that you can tell what it's doing. It's like, oh, that's what we're doing. We're saying that reset is 12 and enable is 11. Okay, I know what's going on. This whole line is just for us humans to know what's going on. We could have just passed the numbers directly in here. Okay, now we have the liquid crystal display. enable the code written for it, but we need to actually tell it to do something. So that's what this first bit is. First thing is we need to tell the code that this is a 16 by 2. Right? I mentioned that before. We need to say this LCD is a 16 by 2. Now, if we make this a 1, it's going to think it's only one line. It's only going to use one of the lines. I'll show you that later when everything's running. And now we want to actually, drum roll please. What do you want to say? You want to say hello world, or do you want to put in something else? Hello YouTube?
Oh yeah, hello.
Sure, we'll do hello YouTube. Now, we're going to skip this last bit in the loop for a second. We're just going to do this setup. And now, who wants to do the drum roll?
I want to.
You're going to do it? Okay, everyone's doing drum roll. We're going to hit send. And then... Did it happen?
No.
Well, I did this earlier to make sure that I knew what was going to happen. Remember how I said you have to turn the potentiometer to change the darkness?
Yes.
So it's very likely that when you set it up, that could happen to you too. So when you change, see how it's kind of changing how dark and light the hello word is?
Yes.
That's because I'm turning this and it's changing how much voltage is going in. Please don't mind the dog. She's just jealous that we're all hanging around without her. The potentiometer here, we had to turn that so hello YouTube was visible, okay? So that lets you adjust it. Now, notice that this Arduino code had setup and loop. Well, on the Arduino, the setup is code that runs once when the Arduino starts up. And then in the loop, that's something that runs over and over and over again.
Yeah.
So we could get this to change to something else. So in the example, it has LCD and it sets the cursor to the first position of the second row. Yes, it's 0 and 1. In many languages, and this is C++, in many languages, the first thing is actually 0. You start at 0 and then you count from there. So the first location is 0, the second location is 1. So the 0 column is the first column, and the first row is actually the second row. Okay? And then we tell the LCD to print something else. Here, millis is short for milliseconds. And this is how many milliseconds it's been since the Arduino has turned on. A millisecond is 1,000th of a second. So if we divide by 1,000, we get seconds again. This is going to be how many seconds since it turned on. So when I hit upload, what do you think it's going to print on the second line?
How many seconds?
And do you think it's going to keep changing or just stay the same?
Keep changing.
Very good, because it's in loop. So every time loop runs, it's going to print it again. And every second, it will be a new number. So we're going to hit send, blinking lights on the Arduino, and
2, 3.
It is counting up. Cool, huh? So that is a very, very basic tutorial of how you use code to make hardware do something.
Cool.
Okay? In the future, we'll go over more cool things like there's a fan, right? We can make it turn the fan on. There's a joystick where you can use the joystick. And so say maybe we say when you push up, it makes the fan go faster, and push down, it makes the fan go slower. We can do stuff like that. We can think about some ideas later, but that's what this kit is all about. It's about getting the tools to just do some basics. There's a bunch of little parts in here, and there's some basic things you can do. And there's even a little wire in here that you can use to plug it into a battery. And so we could get this set up to unplug from the computer. Now the code is already written and it's already on the Arduino. And we're going to plug the battery in. And it works without the computer. See? So we could use the battery. We could set this up to have like Christmas greetings or something like that, and then go put it in the window, and then it will stay on because that's battery. Any last questions?
No.
Okay. Well, do you have one, Brother Yeti?
No.
No?
Yeah.
Yeah.
So these ones is for another thing, right?
Yes, he's asking about this pile of wires over here. There are more wires because you can do more projects. We didn't need them all for this project, but there's a lot more you can use for other things too.
Yeah.
So I look forward to showing you guys even more projects. I had fun playing with electronics as a kid with my dad, and I want to show them to you as well. And while I'm at it, share it with the rest of you on YouTube. I hope you all have a great day. And one last thing I forgot to mention, this kit here, right? It's a really cool kit. It is what, like 45 or 50 bucks on Amazon? Yeah, 45 bucks on Amazon. So I'm going to put a link below if you want to look at that. It is a lot of fun. There's a lot of great stuff in it. There are other kits as well. This is just the one that my wife got for me. There are other kits with even more things, right? So more breadboards, more wiring harnesses, just more stuff. There are also really cool robotics things. I have one similar to this as well that my wife got me in a previous year. This one has a little bit more than mine did. Mine does not have the camera, but it's got these sensors here, and so you can code it up. There's a phone app as well. You can use your phone to use your phone as a controller using Bluetooth. You can set it up to where it will find its way through obstacles. It's not perfect, but it's a lot of fun. You can and it has an obstacle avoidance thing where you can set in the app to tell it to avoid obstacles, and it will use these ultrasonic sensors to tell if it's getting close to things, and it will stop and turn the other direction. It's really fun. It was a lot of fun to put together. It's been fun to play with the kids, and it's just a great way to learn how to make electronics, do things in the real world. I hope you enjoy. Okay, everyone wants to say goodbye.
Bye.
Bye. Where's the hand? We're missing a hand. There's the hand. Mrs. Yeti. There we go. All the hands. Bye.